Assalamu alaikum wa rahmatullahi wa barakatuh. Good day, pupils. How are you doing today? I hope you are doing fine. Today, inshallah, we are going to continue from where we stopped. Last week, we did how to turn on an LED. And today, inshallah, we are going to learn how to connect electronic components. Connect electronic components. And if we follow along, we'll be able to learn different ways of how to connect the component we've learned so far. At the end of today's lesson, we should be able to list the ways in which we can connect some electronic components, connect LEDs in series, connect LEDs in parallel, and add switch to our circuit. Connection. What is the meaning of connection? Connection means attaching, joining, assembling different electronic or electric components together. It means connecting, joining, assembling, merging two or more components together. And what are these components? We have the LEDs. As you all know, LED means light emitting diode. We have the resistors. We have the batteries. We have the switches. And these components cannot function on their own without connecting them to one another. A switch cannot work on its own. An LED cannot work on its own. The resistor cannot work on its own. The batteries cannot work on their own. We have to connect them with wires, jumper wires. We have to connect different electronic components using the jumper wires. And we use this other kind of cable and the connector, which is called battery cap, to hold firm the connection from the battery. So whenever you use the battery cap on the battery, you will be assured that your wire that is attached to the battery is firmly attached, which means it cannot disconnect. So today we are now going to list the types of connections. The types of connections. The first one is the series type of connection, while the second one is the parallel type of connection. Parallel type of connection. So in the series type of connection, we have group of LEDs that are connected to the resistor down to the battery. This is the electronic symbol for battery. This is the electronic symbol for resistor, while these are the electronic symbol for LED. And I told you in the previous lesson that when two arrows are pointing out, meaning the LEDs are dissipating light and it's giving out light, which means it's an LED. Or whenever the arrows are pointing in, meaning it is a photodiode, it is accepting light before it can be able to function. So here we have the plus and the minus. The plus and the minus. The positive and the negative. So the plus means the positive, which is the anode, while the minus means it is negative, which is the cathode. So we have anode and cathode, anode and cathode. So this anode, for the series type of connection, the cathode is connected to the anode, and the cathode here is connected to the anode of the third LED. That is, the negative here of one LED will be connected to the positive, and the negative of this LED will be connected to the positive, leaving the positive connected to the resistor, and the negative will be connected through jumper wire to the negative terminal of the battery. As you all know that the shorter terminal means the negative for the battery, while the longer terminal means the positive for the battery. So when the tail is connected to the head, that means it's a series type of connection. Negative to positive means a series type of connection. And at the end, we use this resistor so that it can limit the flow of electric current. Because if we do not put this resistor here, it will end up damaging these LEDs. That's why we have to limit the flow of electric current so that the LEDs will be able to survive the current that is passing through it. Here's a real example. You have 6 LEDs connected to a resistor down to the positive terminal of the battery. And in our previous lesson, we learned that the longer terminal is the positive, while the shorter terminal is the negative. So now let's take a look at this. The shorter terminal is connected to the longer terminal. Short to long, negative to positive, negative to positive, negative to positive. And then the negative here will now be connected through a jumper wire to the negative. That means negative of the last LED to the negative terminal of the battery. While the positive terminal now, in order for this LED not to get destroyed, we have to connect this soldier man here, which is the resistor, so that it can limit the flow of electric current to avoid the LED to get damaged. So we have to apply resistor here. So in this kind of connection, it's a series type of connection. Now let's move to the other type of connection, which is parallel type of connection. In the parallel type of connection, here we have the battery, the shorter and the longer terminal, and we have the shorter one connected to the negative terminal. As you all know that this negative sign, this sign here indicates negative, while this other sign indicates positive. So and this is the anode and this is the cathode, and we know that all this is an LED because it is giving out arrows. So and the positive is now being connected to a resistor. So all these LED have their own resistors. This one has its own resistor connected to the anode, that is the positive side. A resistor connected to the anode, positive. A resistor connected to the positive side of the LED. A resistor connected to the positive side of the LED. And all these resistors now are now being connected together by jumper wires down to the positive terminal of the battery. And all these negative are joined together to the negative terminal of the battery. So when we have this type of connection, we are having the parallel type of connection. Here is a real example for a parallel type of connection. We have the longer side, which is a positive, 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 all are connected with their own resistors. And at the end of the resistor, we have a wire connecting all the resistors together down to the positive terminal of the battery. and here we have the negative side of the battery connected through a jumper wire to all the negative terminal of the LED. So when we have this type of connection, it means we are connecting a parallel type of connection. Now let's move to the other segment, which is switches. Switches. I know it's not a strange word to us. We have them in our houses, we have them in our car, radio or TV sets, game player, and whatsoever. They are not just for fashion. They are used to turn on or turn off our electrical or electronic devices. Let's take a look at this diagram carefully. You can see this sign, it's closed, right? So meaning that this LED will be glowing, it will be working. Look at it, it's on, meaning it is touching one another, meaning it is glowing. Let's take a look at this battery. When current flows through this place, when it is open, it doesn't touch this place, and that means the LED will not glow. But when the current is passing through, and the current is passing through, meaning it's touching this angle, the LED will start glowing, meaning it will start working. So this is a practical example of a switch, on and off, to on and off. And this is what happened to our electrical supply, maybe the switch we use to turn off and on our bulb. Whenever we press it to the other side, it will stop touching the one terminal of the wire, and our bulb will not come on. But when it touches the other end of the wire, meaning our bulb will on. And there's this saying that a perfect engineer always have control over a system. Let's take an example. Somebody that invented a car without a control, no brake, no slowing down. The person did not make it faster. The person did not make it go slow. The person did not make it to stop. It means that what he has invented is useless, because imagine you want to stop a car and you don't have a brake. It's either you quickly run out of the car and apply maybe wedge it with some stone, or you just leave the car going till it gets to the end point. I don't know what can stop it except God. Okay. A switch or switches are components for making connection or break connection in our electronic or electric circuit. So they are components that are used to make connections, or we can use it to turn off the connection in our electronic or electric circuit. So we have different types of switches. Here are different types of switches. We have the one we can just pull and push. We have the one we can press, that is the push button. We have the one we can press and etc. We have the one we can turn around or move around, we can rotate. They are all type of switches. Here is our assignment for today. What is a switch used for? List the two types of connection you know in an electronic circuit. Describe how to connect the two types of connection mentioned. The two types of connection mentioned, that is in number 2. Thank you very much and have a wonderful day.